Hello, Assalamualaikum, and good evening. Before we are going through, let me introduce myself. My name is Almi Hakim bin Ahmad Nazmi. My fellow friends is Ahmad Hakim bin Muhammad Nazir, Muhammad Shakir Ashraf bin Norden, Amirul Zakwan bin Mazli. We all from BMMD Section 2. Okay, now we are going to talk about torsional loadings evaluation from actual structure, which is we choose ratchet as actual structure for this mechanic project. Okay, first let me explain about adjective. To determine the behavior of material, they under torsional forces. To determine stress distribution within the member under torsional loadings. And to determine mechanical properties such as modulus of elasticity in shear, yield shear strength, ultimate shear strength, modulus of rupture in shear, and ductility. Okay, next introduction. Torsional loading is a type of mechanical testing and test component to a specific degree, with a specific force or until the material fails in torsion. Torsional loading is the load that imparts the turning moment or the torque, the wrenching of body by the exertion of forces tending to turn one end or part about a longitudinal axis while the other is turned in the opposite direction. Okay, an application of these torsion loadings, it used in daily life application and plays an important role in determine how much force and in which direction is required for carrying out a certain task. Next, it is applicable for testing brittle materials such as tools, steels, and cast iron. And lastly, in many areas of engineering applications, materials are sometimes subjected to torsion in services. For example, drive shaft, axis, and twister drills. Okay, in this part, we have actual structure of the chart and free body diagram. From free body diagram, we have a force, length 16 centimeter, and the diameter is 2.6 centimeter.
Hi, my name is Ahmad Haikal bin Muhammad Nasir and I'm going to present calculation for our project. First, we need to calculate polar moment using this formula. Given that the diameter of the wrench is 2.6 cm, so the radius will be 1.3 cm. After calculate it, we get J equal to 4.49 times 10 power of negative 8. Next, we calculate shear stress for this wrench using this formula. We assume that the shear stress modulus for this wrench is 68 gigapascal and we get T equal to 269,400 Newton meter, which is the maximum torque that can be absorbed to this wrench. Then, by using the equation of equilibrium, we can find the maximum force that can be applied to this wrench, and we get F equal to 168,370 Newton. And at last, we calculate factor of safety, and we get 9933.63, which is a very high value, and it ensures that this wrench is safe to use.
Moving on to the discussion, the torque mechanism acts as a twisting structure moment. Axial loads produce a uniform or average stress across the object's cross-section, while torque produces a stress distribution across the cross-section. When torque is applied to the structure, it twists along the road's long axis while maintaining a circular cross-section. The shear stress increases as the angle of twist increases. Because twist causes a shear strain, we can expect torque to cause a shear stress. The relationship between torque and shear stress is T equals to rho T over J. J as the second polar of moment area of the cross-section, it is referred as the second moment of inertia. Second moment of inertia are known as the second moment of area, which is measured of resistance to bend. The less the beam bends, the greater the moment of inertia. Next, the formula for solid rod when the C is the inner radius is J equals to pi 2 over C to the power of 4. Furthermore, to calculate the FOS, which is a safety factor when the ratio of the ultimate strength of a material to the actual stress when in use, the ratio between force that is applied to a component in system with minimum breaking strength. The formula of the factor of safety is equals to T max over T actual. Since the FOS is high and more than 12, it can be proved that the shaft is safe to use.
For conclusions, we had to choose the region as the structure to study about the torsional loading evaluations. Next, we can finally achieve to determine the behavior of material under the torsional force, which is the torque is applied through the structure and create a twist along the road. Identify the product quality based on its material to avoid any failure. The structure that been used was evaluated by using some calculation and simulations. And by calculations, the maximum shear strain is 29400 Newton meter. This indicates if the torque is applied more than that, the structure will break. Nevertheless, the research shows that the torque requirement is 1683750 Newton. That's all. Thank you.